Hello everyone, in this video tutorial we are going to talk about resistance and resistivity and see a few problems, how to solve them. The first question goes as two materials have different resistivities. Let's say this is your material A and this is your material B, and you draw two wires out of them, A and B wire. Okay, the length is same but the resistivity is different. Let's say the resistivity here is rho A and this is rho B, and let us suppose one of the resistivity is greater than the other. This is what question is saying. Is it possible for each wire to have the same resistance? So yes, it can be possible, because if you watched my previous video on resistance and resistivity, we discussed that, and we also saw one problem where if you have a material, even if the length was larger in that case but the area was more, or the wire was thicker, okay, then the resistance value was less. So you can see there they both bear the inverse relationship. So let's see what's the option, what are the options available to us. Yes, if the material with the greater resistivity is used for thinner wire. So let's me explain this option a little bit. So if you have a thinner wire, right? So the wire is thin, so the area will be less. So I will say that area is less. When area is less, because they're inversely proportional, resistance will be higher. So that means this is not the scenario, because we are trying to reduce or maintain the resistance. So if already the resistivity is higher, resistance will be higher already, and if you are trying to thin down that wire, resistivity will increase instead of balancing out. Let's look into the B option. Yes, if the material with the greater resistivity is used for a thicker wire. This sounds like an option over here. Now what was the scenario? Let me rewrite the formula over here. So we have R is equal to rho L upon A, and it's saying the material with the greater resistivity, you make a thick wire out of that, right? So resistivity is already higher, but you make a thick wire, so you are trying to increase the area. When you try to increase the area, resistance will decrease. So yeah, so the resistance was high earlier, but if you draw a thick wire out of that, the resistance will drop, and yes, then you can make a similar or same resistance wires out of them. So option B is the right option for this. Moving on, how does the resistance of a copper wire change when both length and diameter of the wire are doubled? So for this, we have to write the formula and do a little bit of calculations. And because here it is talking about the diameter, not area, so let me write the formula in the form of, let's say, diameter. So it would be pi d square upon 4, right? So this 4 will go up. So 4 rho L upon pi d square. This is what I have in terms of diameter. So let's explore. What we are doing here, both the length and the diameter are doubled. So now you're doing like this. So 4 rho, the length is becoming, so let's say initially they are like this, now they're becoming twice of that, and the diameter also, um they're saying it is doubled, so diameter I'm also trying to double over here, so it's doubling like this. Okay, so let me simplify this thing over here. So I have 4 rho and then 2L dash, and then I have pi in the bracket, I have 2D dash, so it would be 4D dash square. So this 4 and 4 can cancel, so it will become 2 rho L dash upon pi D square, right? So what just happened over here? And did it increase or did it decrease? So it decreases by a factor of 2, right? Earlier it was 4 times, but now it is 2 times. So we will choose the option number A for this. It decreases by a factor of 2. Moving on, question number 5. A resistor is connected between two terminals of a battery. The resistor is a wire, right? So let's say you have a battery and then you connect a wire. Okay, wait. So you have a battery and then you connect a resistor to that battery. Okay, so there are five options. They're saying the following five options give possibilities for its length and radius in multiples of L naught and R naught. For which one or more possibilities the current in the resistance will be in the resistor will be minimum. Okay, so let me write the formula first. R is equal to rho L upon A. Okay, and in here they're talking about rho R naught, the radius. So basically he's saying that can you convert area into pi r square, because here we are talking about L naught and R naught, and the options are also given to me in the form of L naught and R naught. So it's a good idea to already convert it to convert from area towards this thing, okay, by substituting this formula. A is equal to pi r square. Now moving on, let me just discuss the options one by one and then we can see. Okay, so the option says, the question says that the current in the resistance should be minimum. So current is minimum when the resistance will be higher. So we have to look for the cases in which the resistance will become the highest. So let's start with the A option over here. So for the A option, they're just saying if you have L naught and R naught. So let me write that. So R is equal to rho L naught upon pi R naught square, right? So this is my option A. About B, option B. If your length is half L naught and radius is half as well. So let's do that. So rho L naught, it is half L naught and then pi R naught square, and it is also a half. Okay, so let me just write it in this way: 0.5 R L rho L naught. Okay, so half can be written like this, and then if you see over here, I have pi R naught square, and then over here it was 0.5 square. So 0.5 square, it will go on the top and it will become like this. Oh, it will become 0.5 square. Okay. So let me just see that I have, okay, yeah. Okay, no, okay, wait. So it will not be 0.5 over here. Just one second. So if I want to do 0.5, then let me do 0.5 over here. So it would be 0.5 R naught squared. Let's do that. So 0.5 R naught square, right? So this is what I have. And then I have 0.5 times 0.5, which would be 0.25, right? So let me just write that over here. Okay, and then I have pi r naught square. Okay, so what I'm left over here, 0.5 divided by 0.25. So you will be left with 2 over here. Okay, so let me just write that. It is 2. So you can use your calculator as well. Okay, so this is what I have. So I have twice of this number. Okay, so let's say in this case the resistance did increase as compared to the initial value. So it's twice of that. Let's see the option C. For option C, you have 2 L naught and 2 R naught. Okay, so let's quickly plug that numbers. R is equal to rho L naught. I have 2 over here, and then pi R naught square. Okay, 2 R naught square. Okay, so let me just quickly carry down that calculation over here. So I have R is equal to rho, and then you have 2, right? And then in the bottom you have 2 square, which is 4, and then you have pi R naught square, right? So this true and then this true. So I have r sorry, rho L naught 2 by r naught square. Okay, or you can simply do 2 divided by 4 is half, right? So in this case, what happened, if you see resistance decreased, okay, but we are looking for the increasing scenarios of resistance because the question is asking when the current will be minimum. So this was our option C. Let's do D part now. So again, let's start by writing R is equal to rho. He's saying multiply the length with 2 and then you keep R naught same. So let's try that. By R naught square. So in this case, what happened? Let me just rearrange 2 rho L naught upon pi R naught square, right? So in this case also, if you notice, the resistance is becoming twice, which is already here, right? So this is your original value and this is becoming twice of that. So this is also increasing. So let me just write or tick this option and then this option as well. Both are corresponding to the 2 times. Because the question is also saying one or more possibilities, so they seem like the possibility. And then we have one more, the last option. So they're saying r is equal to rho, multiply the length with 8, so 8 L naught upon pi r naught square. By the way, you can stop the pause the video and try the things yourself as well. So 2 r naught square, right? So we will have to simplify over here. So 8 I'm bringing to the front, rho L naught, and then I have pi r naught square. I had 2 over here, so 2 square will be 4, right? So I have 8 divided by 4, which is 2. Then I have rho L naught pi r naught square, right? So this is also 2. So this is option also seeming like one option. So if you notice over here, all of these options, which is option number D, option number E, and option number B, they're all twice. So we will say that B, D, E. Okay, B, D, E are the right answers for these questions. Okay, so this is it for today. And yeah, we'll see you in the next video. Thank you.